Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Colorful Squares by Baron. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We have German whispers, where adjacent digits along a green line have a difference of at least 5, and I call these whisper 5 lines because a setter came up with that name, and I think it made a lot more sense because it's very easily extensible. We have, so for an example, for whisper 5 slash German whisper lines, if this were a 3, this would have to be an 8 or a 9, because the only digits which are 5 or more away from 3 are 8 and 9. And that's an example of how German whisper 5 lines work. We also have Renban lines, where digits along a purple line form a set of consecutive digits in any order. So, for example, you could have something like, say, 2, 5, 4, and 3 here, and that would be valid because these digits form a set, 2, 3, 4, 5, of digits that are the consecutive digits. But you could not have, though, something like, say, 5, 1, 3, 4, because 1, 3, 4, 5 is not a set of consecutive digits. And those are examples of how Renban lines work. We have parity lines, where along a red line, every pair of consecutive consecutive cells on the line must contain one odd digit and one even digit. So if we did have, say, a 3 there, this would have to be even, because 3 is odd here. And every pair of cells on a parity line must have an odd and an even digit. And since this is odd, this must be even here. So that's an example of how parity line works. We have Nabner lines, where digits along a yellow line form a set of non-consecutive digits in any order. So, for example, if we could have something like, say, 6, 9, and 1 here, and this would be valid because none of these digits are consecutive with each other. Normally, you also say you can't have repeats, but since these are all in the same row, actually, they're all in the same box, so therefore they can't have repeats ever, anyways. We have region sum lines, where box borders divide a blue line into segments, which have the same sum, and different lines may have different sums. So, for example, these digits here must sum up to the same sum as these digits here, which must sum up to the same sum as these digits here, which must sum up to the same sum as these digits, which must sum up to the same sum as these digits, which must sum up to the same sum as these digits here. So that's, so basically, yeah, the box borders divide the blue line into segments, and those segments must have the same sum. So actually, let's look at this. Then this digit must be equal to the sum of these two and these two, and the same sum must sum to the same sum as this one, and sum to the same sum as that, and there, and there. So that's an example of how region sum lines work. We have modular line, where any run of 3 sequential cells on a teal line must contain one digit from each of the sets 1, 4, 7, which is 1 mod 3, 2, 5, 8, which is 2 mod 3, or 3, 6, 9, which is 0 mod 3. So, for example, if we had these 3 digits, we could have something like, say, 5, 1, and 6. And this would be valid because 1 is a digit from 1 mod 3, 5 is a digit from 2 mod 3, and 6 is a digit from 0 mod 3, and we have one of each. So that's an example of how modular lines work. And finally, we have black dots, where digits in cells joined by a black dot are in a 1 to 2 ratio. So, for example, if this were to say 2, this would have to be 1 or 4 to maintain a 1 to 2 ratio between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Where do we start here? Let's start with the black crop key dots. So here we don't know. It's 1, 2, 3. So the possibility for black crop key dots are 1 and 2 to be in a 1 to 2 ratio, 2, 4, 3, 6, and 4, 8. But these digits cannot be consecutive because they are in an Abner line. So this can only be 2, 4, 3, 6, or 4, 8 there. These have to be different sets. All of those work, except for 3, 6. So 1, 2, 2, 4, or 4, 8 works there. So that means these two digits, if it's 1, 2, it's going to be 1 mod 3 and 2 mod 3. If it's 2, 4, it's 2 mod 3 and 1 mod 3. And if it's 4, 8, it's 1 mod 3 and 2 mod 3. So that means these digits have to be 3, 6, or 9 here. So these are 3, 6, or 9, and 3, 6, or 9, because we have a guaranteed 1 mod 3 and a 2 mod 3 in these two cells. So that means we don't have a 0 mod 3 for these 3 cells, or a 0 mod 3 for those 3 cells. Okay. That's interesting. We have an odd, even pair here. So that means this must sum to an odd sum. Because 2 odds and 2 evens gives you an even sum, right? 2 odds forces those odd digits to add up to an even sum. The evens digits always add up to an even sum. So the total of this is even, but we have 45 minus this even sum, which is an odd sum minus an even sum, gives us an odd sum here. So again, these must add up to an odd sum. It's the same as this, adding up to an odd sum. So this must also add up to an even sum. So must this. Oh, that kind of makes sense. And so must that. And so does this. So this has to be odd. So we have to have, if we have odd, even, odd, that's an even sum there. If we have even, odd, even, that's an odd sum. So that's not helpful there. Here we have this digit. Okay. We have these digits must be consecutive. These digits must add up to what this digit is. So what are the possibilities? Okay. So one thing that's interesting, can this ever be 5? Well, specifically, can we ever have 9 in one of these cells here? Can we have 6 through 9 here? This would then have to be 5 because these digits must add up to that digit, and therefore they're smaller. And that would force us to be 5. And the answer to that is no. Because if this is 5, this becomes 1, 2, 3, 4 here. That means we can't have 1 through 4 here on the Nabner line. So the Nabner line would have to be 5, 7, and 9 to be valid. But then that parity line eliminates that possibility because 6 and 8 are both even, and those are the leftover digits. So this cannot be, we cannot have a 9 here. Where can the 9 be in this box? It has to be here. So this is 9. That means all the other digits must add up to 9. So I think this has to be 1, 8, or 2, 7 here. 9 eliminates 9 here. So these are all 1 through 8. And for this, for box 7, it has to be 3, 4, 5, 6 as the consecutive digits, but these don't have to be. For this to be a valid renban, it's 3 through 6, because if we can't have 1 and 8 and 4 and 5. You can't have 4 and 5, because then that break up one. You don't have 4 digits that are ever going to form a set of 4 consecutive digits then, of the remaining digits. So 9 cannot be here. 9 in box 4 must be one of those 3. Has to be one of those 3 there. So these sums are all the same. They add up to an odd sum, obviously. Do we have anything else? I don't really know. So these we know add up to 18 because they're equal to 9 times 2. So that's an even sum. This is odd because it's a parity line with 2 digits, and therefore it's an odd and even sum. So that's an odd number, which means this must be an even number here. Does that really tell us anything? I'm not sure. Hmm. 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 Okay, the interesting aspect, these are all the same sum. So these are all the same sum also. Does that really tell us anything? I'm not sure. This is the same sum. Okay. So what are the possibilities? What's the most they could be? Well, this is 4 and 8 at most here. So then it could technically be with 7 and... No, it can't be. At least in this box. Cannot be with 7 and 9. Because 4 and 8, 7 and 9 would eliminate 3 high digits, and the only remaining low digit would be 6, which cannot be between 2 unique digits here. So technically it could be 4, 8, 6, 9 does work. Because 7 could be between 1 and 2. But then that would leave 5 here. And then 3 remaining, which does not work. Because then these would not be the 5 and 3 would be the same, would have to be the same parity as each other. So 4 8 plus 5 9 works as the maximum amount. Or 4 8 and 6 7, which is less actually. 4 8. Right, 5 9 works. Because then we could have 1 or 6 or 7 here with 1 in between 6 or 7. And then it would be 2 3 as a pair as a possibility. Okay. So 4 and 8, 5 9 is the most. Oh, excuse me. That's equal to 4 9 plus 5 8, which is 26. 26 is the most these lines could add up to. 15 obviously is the least. But it's not going to be 15. These have to have a difference of at least 2. Oh, well, there you go. So, what's the minimum that this set of cells could be? Actually, let's do the Renban. Renban. So 26 is the most. But it has to be an odd number because of box 6, right? We have 2 odds and 2 evens. So it's really 25 is the most this could be. Actually, let's not use this. Let's use this one. This has to add up to an even sum. So, if we have 3 and 6, if we have 2 and 4, the other two digits have to be 6 and 8, which is 20, which means this sum must add up to 25, which is the most this could add up to. So therefore we know that sum is 25. If we have 4 and 8, the problem with like having a 1 is you need another odd digit so that this sums up to an even sum. So that doesn't quite work. So then you would have to still get a minimum of 2 and 2, 4, 6, 8 for this to work. Now, what happens if we have 3, 6 here? So if we have 4, 8, again, you can't have 1 plus another odd digit because 3, 5 is consecutive with 4, 7, 9 are consecutive with 8, and therefore this doesn't add up to an even sum, which it does have to because these are all the same sum. And so these must be all the same sums for the squares. So 2 and 4 and 4 and 8 lead to 20 for this square, which is the minimum this sum can be, and the maximum this can be, which matches the maximum here. What about 3 and 6? 3 and 6. Oh, you actually want the largest sum. Yeah, you want the largest sum possible. Okay, so that's not helpful. So you can have 2, 4, 7, 9 here. That's 16. plus 4 plus 2 is 22. That means the remainder is 23 here. So then this has to be 23 or 25. I don't think we can get a even larger number with 3 and 6, right? 3 and 6. The problem is... yeah. So this must add up to 23 or 25 here. What happens if we have 3 and 6? If we have 3 and 6, the most on the Nabner lines could be 9, but then the other one is 1, right? Yes, 7. So 3 and 6, you either have 1 of 8 or 9. 5 and 7 are consecutive with 6. 2 and 4 are consecutive with 3. And you would have to have 1. So it would actually have to be 1, 3, 6, and 8. Because you have to add up to an even sum. That's 18. Which means the remaining digits must add up to 27. But that's too large for this sum here. As we've showed here. So this cannot be 3 and 6 here. Can it be? It could be 4 and 8 still. We could have 2, 6 here. So this must add up to 23 or 26. Sorry, 23 or 25 for the sum. We can't add up to more than 26 for box 1. So that means this cannot be 1 and 2 here. This is going to be too small for that. This sum would be too small for this sum, which would make that too large. Technically, the most you could have on a Nabner line in general would be 3, 5, 7, 9, which would be 24. So this would be 21 at minimum, technically. But because this is a 1-2 ratio, that restricts what we can have. So 2, 4 could be with 7, 9 here. That could be possible. So again, this is 23 or 26. Sorry, 23 or 25 that this sums up to. If you have 1 and 2 here, obviously it can't be. The rest can't be 23. Minus 3, that would be 20 for 2 digits, which is not possible. 2 and 4 could work. Two and 3. So one thing we are guaranteed is 4 has to be here then. Okay. Two and 4. So to add up to 23 with 2 and 4, that does work if it's 9, 8. Except that that's not... okay. So what happens if this is 2 and 4? So that means this must be 9 and 8. 6 plus 8 and 9 is 23, which is the minimum this sum can add up to. That means we have only one even digit here, and we're guaranteed an even digit here, so this must be the even digit, which is 6. That means we have odd and odd here. Well, 5 can never be on a Whisper 5 line, because if you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 more to 5, you get 10 or more, which is not a digit. So then 5 would have to be here. This would be odd. But the problem is you have 1, 3, and 7 left, and none of them are 5 away from the other 2. So that would fail. So this cannot be 2. So this is either 3, 6, or 4, 8 here. What happens if it's 4, 8? That's 12. 23 minus 12 is 11. 25 minus 12 is 13. So, if this is... Let's try 3, 6. Maybe that'll give us 3, 6. 23 minus... what is it? 9? It's 14. Cannot have 6, so it'd be 5, 9 there. That could work. What about 25? 25 minus... That would be 7 and 9 there. Then. So we'd have one high digit. It would have to be 8. We would leave 1, 2 would have to be here. That could be 4. That would be 5. So that does kind of work. So that also works. Okay, so what does that mean for this? That means, again, this adds up to 20 or 22. That means this must add up to 20 or 22. Well, to add up to 20, 4 digits adding up to 20. Can you add up to 20? I don't know if you can. 3, 4, 5, 6 adds up to 18, because it's 3, 6, and 4, 5. 4, 7, and 5, 6 is 11 each, so that adds up to 22. So for a renban, yeah, you can't add up to... You cannot add up to 20 at all. It's 22. So then that must match this. And then this must be... So this must be 22. And this must be 22. And I guess this must be 22, right? Because these add up to 23. So this is 4, 5, 6, 7. That leaves the remaining digits in that box is 1, 2, 3, 8, 9. So that should be 23. Yep. That means this must add up to 22. Cannot be 4 and 8, because that adds up to a maximum as a Nabner line as 2, 4, 6, 8, which is 20. So it has to be 2, 4 here, which means this has to be a 7, 9 pair to add up to the most, which means the remaining digits in this box are 1, 3, 5, 6, 8. That's 22 or 23, right? 1, 5, 6, 8, yes, is 20. And then 3 is 3, obviously. Well, that leaves... So, again, if we try to have 3, 6 here, that's 9. 20... Oh, it could be 5, 9, though. We do know that 4 has to be one of these... Oh, okay. 4 remaining in row 3 has to be one of these 3 digits, because it's in the run band here, it's in the Nabner line here. If we tried to have 3, 6 here, to add up to 23, we'd have to have 5, 9 here. But then this 4 wouldn't work, because 4 can only be next to 9 on a Whisper 5 line. And the 9 is already taken by being on this region sum line, right? 3, 6 is 9, plus it would have to be 5, 9 here. So then this cannot be 3, 6. It must be 4, 8 as a pair. That eliminates 4 and 8 in the rest of the row. So no 8s there, which means we give a guaranteed 8 here. We have a guaranteed 8 here. Also, we need a 7 somewhere here. Right, in row 3. So it has to be 7 there. So this is 12. That means this must be 11 plus the 12 to add up to 23. No 4, 7, no 3, 8. It's either 2, 9 or 5, 6 here. So this is either 2 and 9 or 5, 6 is a pair. 7 can only be next to 1 or 2 here. Where are 5 or 6 in row 3? It has to be here, so this cannot be 5 or 6 here. So we're guaranteed 1 out of 1 or 3 is here. Where's 9? 9 has to be one of those two, so this can't be 9. And we're guaranteed 2 has to be one of these 3, so this can't be 2. Okay. So we have 1 or 2 here. This must be a high digit. It cannot be 4 or 8, so this is 6 or 9 here. That means this must be 6 or 9. We're missing a 3. 3 then has to be one of these two. And what else are we missing? So if we are missing... Okay, this could be... It cannot be 1. If this were 1, we would be with the 3 that we were missing, and that's not possible. So this has to be 1 here. So we know this is 1, and this must either be 6, 3, and 2 there. It can't be 6, 3, or 2. Right. If it's 6, 3, and 2, that would mean this pair doesn't add up correctly. So this can't be 6, therefore this must be 9. We have to have 9, 2, and 3 be there for the parity line. That eliminates 9 and 2 here. This 5, 6 pair eliminates 5, 6 in the rest of the row, so this 4, 7 pair eliminates 4, 7 in the rest of the box. This can't be 4 and row, so this can't be 4, it's 2. This can't be 2, it's 4. This can't be 7, it's 9. That makes that 7. No more 1s here, no more 3s here, because of 3 in the row, 1 in the row. This cannot be 1, 8, or 2, 7. Adding up to 9, it's 3, 6, or 4, 5. We have a 3, 4, 5, 6 quadruplet in column 1, which eliminates 3, 4, 5, 6 in the rest of the column. So this can't be 1 or 7, therefore this has to be 2 or 8. 2 or 8 adds up with 1 or 7 to add up to 9. 2, 8 there. These two digits must be exactly the same as these two digits. Well, what digits can be here? I guess this could be 4 and 5 here, too. They have to be the same as 3 of those digits. Interesting. So this is going to be an odd-even pair. This must be an odd-even pair. This must be an odd-even pair. To add up to the odd to sum, this must be an odd-even pair, so must this, and this must also because of the parity line. Well, this is even, which means the remaining digits both must be odd, because we have 4 evens accounted for in box 4. So these are 1, 3, 5, 7, 9. Obviously, no 3 or 9 there. It's going to be interesting here. So the sum is what? 23. Which means this must sum to 22. Which means we have an extra 1 mod 3 and 2 mod 3. If you add them together, will give you a remainder of 0 mod 3. Also 0 mod 3, which means this has to be 1 mod 3 remaining here to add up to 22. 22 divided by 3 gives you a remainder of 1. And this would be 0, remainder of 0, remainder of 0, remainder of 0, so we need a remainder of 1 here. So this is 1, 4, 7. That means this cannot be 1 mod 3 here. It's 2 mod 3. No 2 mod 3 there. It's 1 mod 3. Okay. So 9 is one of those two. So this is guaranteed. This green is guaranteed to be one of these two, right? That means whichever one is here has to match that. So that guarantees there. So that means it must match one of these three. We do know that these two add up to 9 also, right? Because these two add up to 9 and they can't be here. So they have to be one of these. One of these is guaranteed to be even. One is odd. One of these is guaranteed to be even and odd. So 22 for the squares, or the squares that don't sum up to the same sum. 22, huh? That means both of these digits. Okay, so these are next to two unique digits. So this is guaranteed to be 4, 5, and 6 on this line here. That's already 15. That means the remaining digits here have to be 1 and 7 to add up. Because 4, 5, and 6 all have to be here because these are next to two unique digits on the Whisper 5 line. 5 can't be next to any digit on a Whisper 5 line. 4 and 6 can only be next to one unique digit on a Whisper 5 line. So 23 minus 15 is 8. And we don't have 3, 5 available, or 2, 6, because of the 5 and 6 already taken care of. So this leaves this as a 1, 7 here, which means the remaining digits are 2, 3, 8, 9, triplet. Or quadruplet, I should say. One out of these digits must be a 2 or 8. 8 cannot be here. Or here. Can we have 8 and 4 here? It's kind of the question, right? 8 and 4 is 12. You could have 3 and 6 here. Yeah, that does work. 12 plus 9 is 21, plus 1 is 22. So that is possible. Hmm. Oh, these cannot be 3, 4, 5, or 6. Because if these are 3, 4, 5, 6, they both see these cells, which we know one is a pair that adds up to 9, the other is the other pair that adds up to 9. So therefore, if this is 3, 6, that would eliminate 3, 6 here as possibilities, but we know there has to be a 3, 6 in one of these cells here. So this cannot be 3, 4, 5, 6. It's 1, 2, 7, 8, which means we have a 1, 2, 7, 8 quadruplet in row 9, which eliminates 1, 2, 7, 8 in the rest of the row. So this can't be 1, 2, 7, or 8. It's 4. That means this can't be 4 to 1, which makes that 1 and 2 in a 1 to 2 ratio. So that's 7 there. That eliminates 1 in the rest of the column. This can't be 2 or 7. It's 1, 8 as a pair. That eliminates 1, 8 in the rest of the box and row. So this can't be 1 or 8 or 2. It's 7, which makes that 2. That makes that 8 and 1. 8 eliminates 8 there, so it's 2. 1 cannot be on this Nabner line, nor can 3. This can't be 2 or 7 anymore. 7 eliminates 7 here, so that's 5. 5 eliminates 5 here, so it's 6. So this is 3 and 6, that adds up to 9, because we don't have 4 and 5 available here. This is 5 then. So no more 5 here. This is not 4 or 5, it's 3, 6. That eliminates 3, 6 in the rest of the column, so it's 4, 5, which eliminates 4, 5 there. 4 eliminates 4 there, so that's 5, which makes this 4. This has to be 3, 6, or 9 here. Those are the only digits remaining in row 9. It's 1, 8 pair. 2 eliminates 2 here, so this can't be 7. No 5, 6 here. No 5 here. No 5 here. No 3 or 6 here. So to add up, it cannot be 4, 5, because this has to be a 5. So then this has to be 1 and 8. 1 eliminates 1 there, so that's 8, which makes that 1. 8 eliminates 8 there, so it's 4 and 8. This becomes a 7, 9 pair. That leaves this as a 4 here. That eliminates 4 there. So 4 has to be one of these 2 digits there. We have to have 8, also, that we're missing in column 9. So 8 has to be one of these 2 digits. And we know this can't be 4 and 8 here, because they would both be even next to each other on a parity line. So this has to be a 4, 8 here. We know 5 eliminates 5 here, so it's 1, 4, 6, 7. That means we know there's a 3 remaining in row 4, and it has to be here. Okay. We have the Nabner line here. Okay, this is 1, 2, and 4. That's 7. And these must add up to 22. So it has to add up 15 for the remaining 2 digits. So it's 6 and 9. So we have 6 and 9 there. That eliminates 9 here. 6 eliminates 6 here, so this can't be 3. 9's one of those 2. 9 has to be on the region sum line here. So let's make sure this works. 3, 5, 7, and 8. Does that add up to 23? It does. No 8 here because of 8 in the row. We have a guaranteed 8 there. 8 cannot be here because we have guaranteed 8 there. So that leaves this as 8. 6 eliminates 6 here. The remaining digit here is 3 or 5. So we have 3 or 5 here. 3 cannot be the digit that's here because we have a guaranteed 3 here in row 4. So that means this must be 5, which means this can't be 5. That's 3. That eliminates 3 in the rest of the box. So this can't be 3. That's 8. Which makes that 3. 8 eliminates 8 there. So it's 1 and 8. No more 1s here. No more 3s here. This is 5 with 4 or 8 here. So it's a 4, 5, 8 triplet. We have 3 and 9 on this region sum line. That's 12. So the remaining 3 digits must add up to... Well, we also have 2 there. And 2 has to be one of these 2. So 2, 3, and 9 add up to 14. 23 minus 14 is 9. So this must be either 1, 8 or 4, 5. It cannot, 5 is guaranteed here, so this cannot be 4. Therefore, that makes this 8, which makes that 5, which makes that 4. No more 5 here because of 5 in the row. Where is the 5 in box 5? It has to be here. 3 eliminates 3 here, so it's 6, which makes that 3, which makes that 6. 6 eliminates 6 in the rest of the column. So this must be 1, 2, 3, 9. 1 can't be here because of 1 in the column, so 1 is there. That leaves that as 3. That eliminates 1 in the rest of the row, so this is 4, 6, 7. That eliminates 4, 6, 7 in the rest of the row and box, making that a 1, making that a 9. That makes that a 7. This becomes a 2, 9 pair here. 3 eliminates 3 here, so it's a 5, 7 pair. 5, 7 eliminates 5 there, so it's 6. 6 eliminates 6 there, so it's 5. This can't be 5 or 7, it's 3. No more 3 and 6 there. So 1, 2, 3, 8, 9 adds up to 23. That leaves us as a 6, 7 pair. 7 can't be here because of 7 in the row. So that's 6, which makes that 7. 6 eliminates 6 there, so it's 3 and 6. There's no 3 here. There's no 8 here. So 8 is guaranteed to be here. It cannot be next to a 9 on a Whisper 5 blind, so this must be 2 and 8. That eliminates 2 there, so it's 9, which makes that 2. No more 2 here. It's 3 or 9 there. We have a guaranteed 4 or 7 here to add up to 9. 2, 7, and 4, 5 are all the possibilities, and this has to be 4 or 7. That eliminates 4 and 7 in the rest of the column, so no 4, 7 there, it's 6. That makes that not 6, so it's 5, which makes that 6. Again, no 6 here. 5 eliminates 4, 5 as a possibility, so this must be 2 and 7, adding up to 9. 2 eliminates 2 there, so it's 8, which makes that 2. 8 cannot be next to 9 on a Whisper 5 line, so that's 3 and 9 there. 8 eliminates 8 there, so it's 1 and 8. 1 and 2 eliminate 1 and 2 there, so it's 9. 7 eliminates 7 there, so it's 4, which makes that 7. Makes that 4, which makes that 7. No 2 or 9 here, so this is 1, which makes that 2. 7 eliminates 7 there, so it's 5 and 7. These have to be 4 and a 9. And this can't be 9 because of 9 in the row, so that's 4, which makes that 9, which leaves us as 5 and 3. And that's a solution. Pretty interesting, actually. That was interesting how that worked out. I wasn't really expecting it to flow so well, but it flowed very well, actually. Yeah, the real key was this box here. Well, this box combined with 6. And then I guess it combined with box 2. Yeah, it was all the squares were very important, because particularly this part, right? But these were all very important in their own ways for the squares. Interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.